Our solar system is a vast and intricate tapestry of celestial bodies, each with its own story to tell. Among these, Jupiter, the largest planet, reigns supreme, holding court over a retinue of moons that dance around it in a cosmic ballet. One such moon is Sinope, a small, irregularly shaped body that orbits Jupiter in the opposite direction of its rotation. Sinope is a member of a group of moons known as the irregular satellites, which are thought to be captured objects ensnared by Jupiter's powerful gravitational pull. These moons, unlike their more well-behaved counterparts, follow eccentric and inclined orbits far from the plane of Jupiter's equator. Sinope, in particular, stands out even among its irregular brethren, exhibiting unique characteristics that set it apart and hint at a potentially independent origin. The year was 1914. World War I had just erupted, casting a shadow of uncertainty across the globe. Yet amidst the turmoil, a small group of astronomers at the Lick Observatory in California continued their tireless vigil of the night sky. It was during one such routine observation that Seth Barnes Nicholson, a meticulous observer, stumbled upon a faint speck of light near Jupiter. This faint speck, barely discernible against the backdrop of distant stars, would later be confirmed as a new moon of Jupiter, the ninth to be discovered. Initially designated as Jupiter 9, it wasn't until 1975 that it finally received its official name, Sinope, after a nymph from Greek mythology. Sinope's journey around Jupiter is a solitary one, its path a stark contrast to the more orderly orbits of Jupiter's inner moons. Unlike the Galilean moons, which gracefully waltz around Jupiter in near-circular paths, Sinope follows a highly eccentric orbit, its distance from Jupiter varying significantly throughout its journey. This elliptical path takes Sinope far out from Jupiter, then swings it back in on a close approach, only to be flung outwards once more. Adding to its orbital complexity, Sinope's path is also highly inclined, tilted at a steep angle relative to Jupiter's equatorial plane. Perhaps the most intriguing aspect of Sinope's orbit is its retrograde motion. Unlike the majority of Jupiter's moons, which orbit in the same direction as Jupiter's rotation, Sinope moves in the opposite direction, traveling against the flow of traffic in the Jovian system. In the celestial court of Jupiter, where moons pirouette around the gas giant, a fascinating dance unfolds. Sinope finds itself loosely associated with a group of rebellious dancers known as the Pasiphae group. These moons, each with their own unique characteristics, form a captivating ensemble. This ragtag bunch of irregular satellites named after the moon Pasiphae are characterized by their distant, eccentric and inclined orbits, which set them apart from the more orderly moons. All moving in retrograde motion around their planetary overlord, they defy the usual direction of celestial movement. Astronomers theorize that these moons were once part of a larger body, perhaps an asteroid or a comet, that ventured too close to Jupiter's powerful gravitational field. This larger body was torn apart by the planet's immense tidal forces, resulting in the creation of these smaller moons. The fragments of this shattered object, now bound to Jupiter's gravity, became the moons we observe today, each with its own story to tell. Each moon bears the scars of their violent past, a testament to the chaotic forces that shaped them. Though Sinope shares orbital characteristics with the Pasiphae group, its membership in this celestial family is not without debate. Some astronomers point to subtle differences in Sinope's orbit, suggesting it might have a different origin. These differences, along with its distinct reddish hue, provide clues that Sinope may not share a common origin with the other members of the group. The debate continues, as astronomers strive to unravel the mysteries of Sinope's past and its true place in the family portrait of Jupiter's moons. While Sinope shares the dance floor of the Pasiphae group, its individual steps and appearance set it apart. This moon, orbiting Jupiter, has a unique story to tell. Unlike its predominantly gray companions in the group, Sinope stands out with its distinctive reddish hue, a characteristic that hints at a potentially different origin story. This color difference is not just cosmetic, it suggests a deeper, more intriguing history. This reddish coloration, similar to that of some objects in the outer solar system, suggests that Sinope might be composed of materials that formed in a colder, more distant region of the early solar system. This could mean that Sinope was captured by Jupiter's gravity, rather than forming in place. Adding to its uniqueness, Sinope's orbit, while sharing the general characteristics of the Pasiphae group, exhibits subtle differences that set it apart. These differences are not just in its path but also in its speed and inclination. Its inclination, for instance, is slightly higher than that of the other members of the group, suggesting that it might have experienced a slightly different gravitational history. This could be due to past interactions with other celestial bodies or even collisions. These subtle orbital nuances, like subtle variations in a fingerprint, could hold the key to unlocking the secrets of Sinope's past. By studying these details, scientists hope to piece together the moon's journey through the cosmos. As Sinope embarks on its celestial journey around Jupiter, it engages in a delicate gravitational dance not only with the planet itself, but also with the invisible forces that permeate the Jovian system. This intricate ballet is a testament to the complex gravitational interactions that govern the motions of celestial bodies in our solar system. One such force is resonance, a phenomenon that occurs when two celestial bodies exert a regular periodic gravitational influence on each other due to their orbital periods being related by a ratio of small whole numbers. This relationship can lead to fascinating and sometimes unexpected orbital behaviors. In Sinope's case, it is locked in a secular resonance with Jupiter, a type of resonance that affects the long-term evolution of its orbit. This means that over extended periods, Sinope's path around Jupiter is gradually altered. This resonance arises from the subtle gravitational tugs exerted by Jupiter on Sinope over vast stretches of time, gradually altering the shape and orientation of its orbit. These minute forces accumulate, leading to significant changes. The effects of this resonance are not immediately apparent, playing out over millions of years. It is a slow and steady process, almost imperceptible in the short term. Over time, however, they can have a significant impact on Sinope's orbital evolution, causing its eccentricity and inclination to oscillate, like a pendulum slowly swinging back and forth. This oscillation is a clear indicator of the powerful and persistent influence of Jupiter's gravity. Despite the advances in our understanding of Sinope, this enigmatic moon continues to hold on to its secrets, posing more questions than answers. Its origin story, shrouded in the mists of time, remains a subject of debate, with its unique characteristics hinting at a potentially different past than its supposed siblings in the Pasiphae group. The exact composition of Sinope, beyond the hints gleaned from its reddish color and infrared signature, is still largely unknown. What materials lie hidden beneath its surface? What secrets do they hold about the conditions in the early solar system when Sinope formed? These are questions that beckon further exploration. Dedicated missions to Sinope equipped with advanced instruments could unlock a treasure trove of information, shedding light on its composition, its internal structure, and its geological history. As technology advances and our reach into the cosmos expands, the prospect of unraveling the mysteries of Sinope becomes increasingly tantalizing. Future missions to the outer solar system, equipped with advanced instruments, could provide an unprecedented opportunity to study this enigmatic moon in detail. Imagine a spacecraft, specifically designed to study Sinope, embarking on a journey to this distant world. Equipped with high-resolution cameras, it could capture detailed images of Sinope's surface, revealing its cratered history, and potentially uncovering evidence of past geological activity. Spectrometers on board could analyze the composition of its surface, providing insights into the building blocks of this intriguing moon. The data gathered by such a mission would not only enhance our understanding of Sinope, but also provide valuable insights into the formation and evolution of the Jovian system as a whole. In the grand tapestry of the cosmos, Sinope may seem like an insignificant speck, a tiny moon dwarfed by the gas giant it orbits. Yet, as we have seen, even the smallest celestial objects can hold the keys to unlocking profound truths about our universe. Sinope's retrograde orbit, its enigmatic reddish hue, its potential for a different origin story, These are all pieces of a cosmic puzzle that beckon further exploration. Each new discovery about Sinope brings us one step closer to understanding the intricate processes that shaped our solar system and the myriad worlds that reside within it. The story of Sinope is a testament to the enduring power of human curiosity, our innate desire to explore the unknown, and our relentless pursuit of knowledge.